Good morning, students. I am Suresh Kumar, Assistant Professor in the Department of Electronics and Instrumentation Engineering. In the previous video, that is part 1, the video, we have studied the block diagram of microprocessor 8085 and various functional units and features of 8085 microprocessor and pin details of 8085 microprocessor. In the block diagram of 8085 microprocessor, the previous video shows the microprocessor functions for data processing and data handling. In the architecture diagram also shows that there is a large number of logic functions are connected together. Such a microprocessor perform a particular task by executing a proper sequence of instructions. So the programmer has to know the instructions supported by the microprocessor used in microprocessor system. So in this video we have discussed about the various instruction sets available in 8085 microprocessor and a different format of instruction sets in 8085 microprocessor, and also large number of program to perform a different tasks. So these are the topics studied in this video part 2. The first topic is instruction set of 8085 microprocessor. First of all, what is a instruction set? So the instruction set is the collection of the instructions that the microprocessor is designed to execute. So an instruction is a binary pattern designed inside a microprocessor to perform a specific function. So to perform the specific task or function by the microprocessor is called instruction set. So the entire group of instructions that the microprocessor support is called instruction set. So the collection of the group of instruction in the microprocessor, that is called instruction set. So 8085 microprocessor has a large number of instruction sets is available. That is a 246 instruction set is available in 8085 microprocessor, but small number of set of instruction is available in 8051 microcontroller. In the 8085 microprocessor, each instruction is represented by 8-bit binary value. This 8-bit binary value is also called opcode or otherwise called instruction byte. The instructions provided by the 8085 microprocessor can be categorized into 5 different groups based on the nature of function of the instructions. First one, data transfer instruction, arithmetic instruction, logical instruction, branching instruction, and another one is a control instruction, or otherwise called data transfer operations, arithmetic operations, logical operations, branching operations, and also machine control operations, that is nothing but stack and input and output operation. So these operations are categorized into control operation or otherwise called control instruction. So first one, data transfer operations or otherwise called data transfer instructions. The data transfer instructions load given the data into register, copy data from register to register, copy data from register to memory location, and memory location to register. In other words, we can say that the data transfer instructions copy data from source to destination. The source can be data or content of register or content of memory location, whereas the destination can be a register or memory location. So these instructions do not affect the flag register of the processor. So these instructions move the data between registers to register, between memory to memory, and memory to register, and register to memory. So these instructions copy data from source to destination without changing the original data, and also do not affect the flag status of the flag registers of the processor. The data transfer instruction, the first instruction is a move instruction, MOV. So move instruction is also called copying instruction or data transfer instruction. So copy from source to destination. The opcode of move instruction is MOV. The operand, it may be a register, register to register, memory to register, and register to memory. Okay. So the register, it may be a 8-bit register of source register to destination register. So the destination register is also a 8-bit register. So in this move RD comma RS. So the RD is represents destination register, and RS is represents the source register. So the source register and the destination register may be a BC register, DE register, okay, and a register. So these are the 8-bit register. So the source register content is copied or transferred into destination register. Second one, move M comma RS. So M comma RS, the source register, it may be a accumulator. So accumulator, move M comma A. So the accumulator content, accumulator is also called A register. So A register value is stored into the memory location. So the M is nothing but it's a memory content. It is a 16-bit address. So the 16-bit address is pointed by the HL register pair. So another one, move RD comma M. So the memory content, the HL register point out by the location data is transferred into RD register. The RD register, it may be a accumulator A register, okay, or it may be a B register. So this instruction, move instruction, copies the content of the source register into destination register, or copy the memory into destination register, or copy the source register into memory content. So the content of the source registers are not altered. The destination register content is altered if one of the operand is a memory location. So memory location is also a one of the operand in move instruction. Its location is specified by the content of HL register, the memory content, okay. So memory content is specified by the HL register pair. HL register pair is nothing but it is a 16-bit register. So it holds the address of the memory. For example, move B comma C and move B comma M. So this move B comma C is a register to register copying instruction. Move B comma M is nothing but it is a memory to register copying instruction. So here move B comma C, the C register is a, it's act as a source register, and B register is a destination register. But here move B comma M, so M is a memory location, it's act as a source, and B is a destination register of 8-bit. So here the memory content of 16-bit address, the stores the 8-bit data is copied into a B register. So in this move instruction, so on the content of the source register 8-bit data is copied into a destination register. The destination register is an 8-bit register. This is an example of move instruction, move B comma A. Before the execution, under the after the execution, for say we can say the A register, okay, A register content is 20. So this is hexadecimal number. So the 8-bit data. So A is a 20H, and B register may be any value. It may be stored at previously stored. before the execution of the instruction move B comma A. After the execution, so the A register, okay, the A register content 20 is copied into a B register. So the B register content is override. So in the previous value is override into a new value of A register content. That is, the A register content is nothing but 20H. So after the execution of move B comma A, so the A register content value and the B register content value, both of them are same. That is 20H in move B comma A instruction. So the A register is a source register and B register is a destination register. Both registers are 8-bit register which holds the 8-bit data. So this instruction move B comma A is a copying instruction. So another one instruction move M comma B. So M comma B. So B is a source register, M is a destination point. It's a memory pointer or memory location. So before the instruction, the B registers holds, we can say 30 as a 8-bit data is stored in the B register, but the memory content, that is a HL register pair, that is a HL register pair is pointed in the 2050H, that is address 2050H is address. So the HL register addressing that is a higher byte or addressing under the L is addressing the lower byte of addressing of 16-bit register, that is a 2050H is a address of the memory location. So in this address of the memory location 2050, we can store the data 30 of B register. So before the execution, that is a HL register pair address 2050 memory location, any data can be stored. After the move M comma B, so the B content register is hold or copied into HL register pair pointing memory location, that is a 2050H, that stores the B register value 30. So after the execution of move M comma B, so the memory content value 2050H is altered with previous value and the new value is stored in the 30 of B register content value. So another one example move C comma M. So move C comma M. So here memory is act as a source operand and C register is a destination operand. So the content of memory, so the memory content values copied or transferred into the content of C register. So here we can say that is the memory content. So M value, the memory content HL register pair pointing 2050H memory location data is 40. We can say as a assume is a 40 is a 8-bit data is stored in the 2050H of memory location before the execution. So the C register value, okay, the C register value, it may be a any value of 8-bit. After the move C comma M, so the C register content value is copied or altered or copied or the data is transferred, the 2050H memory location data is copied into a C register content. So the C register is a 8-bit register. So in this way we can copy the 8-bit data from source to destination. First one is a register to register copying instruction. Second one is a register to memory location copying instruction. Third one is a memory to register copying instructions. So another type of move instruction is a move immediate. So move immediate instruction, MVI. So the opcode of move immediate instruction is a MVI is a opcode and the operand. So one of the operand is a 8-bit data. So the data itself in the operand of a MVI instruction. So the operand, one of the operand is a register or memory location. So another one operand is a immediate data is available. So the immediate data is a 8-bit hexadecimal data, 8-bit data. Okay, 8-bit data is directly transferred into a register or a memory location. So in this way the data is already we can know. So the data value already we can know means, so directly send the data into a register or memory location. This type of instruction is a move immediate instruction. So the 8-bit data is stored in the destination register or memory. So the 8-bit data is directly stored into a destination register or memory location. If the operand is a memory location, okay, if the one of the operand is a memory location, the destination memory location means its location is specified by the content of HL register pair. So HL register pair is nothing but it is a memory pointer. It holds the 16-bit address of the memory. Okay. So for example, move b comma 60h. So this 60h is the immediate value of immediate 8-bit data is transferred into a B register. Another one, move m comma 40h. So this is a 40h is a direct 8-bit data is transferred the 40h 8-bit data into a memory location. So the memory location, it may be a any memory anywhere in the memory location, anywhere in the memory location. So the location is pointed out by the HL register pair. So move immediate instruction. So the general opcode is MBI R comma data. So the data is 8-bit. This instruction directly loads a specified register with an 8-bit data given within the instruction. So the register, or register, that is a source register, is an 8-bit general purpose register. This register may be a register, B register, C register, D register, E register, and also H and L register. So the operation is 8-bit data. So 8-bit nothing but it's a byte, 1 byte. So 1 byte of data is directly transferred into a destination memory or the register. So here is an example. This is an example of move b comma 60h and move m comma 40h. So before the execution, the B register content. So the B register content, it may be stores any value, previously any value. But after the execution of move b comma 60h, so the 60h the direct value 8-bit data is transferred into or copied into a B register content. So this 60 is copied into B register content. So move m comma 40h. So the HL register pair is pointed out in the 2050. Okay, this is a HL register pointing location 2050h, the memory location. So in the memory location, previously we can store any value of 8-bit, but before the execution, after the execution of MEI m comma 40h, so the memory pointer pointing the memory pointer addressing 2050h, the data is override into a 40. So the 40 is a direct 8-bit data. So in this way we can directly the data is transferred into a destination register or destination memory location. So the move immediate instruction, one of the operand is a 8-bit data. So we already know the value of the data. We can send the data directly into the register content or memory pointer. So here the memory pointer is nothing but HL register pair. So HL register pair is nothing but it holds the 16-bit address of memory location. So in this way we can alter the register for move b comma 60h, move m comma 40h. So we can alter or override the previous value of B register and M memory location content with 60h and 40h. So another one data transfer instruction is a LDA. So load accumulator. LDA is a load accumulator instruction or operation. So opcode is a LDA. The operand is a 16-bit address. Okay, 16-bit address is a operand. So in the load accumulator, A register is a 8-bit register that is a holds the data of the 16-bit address pointed by HL register pair. So the content of memory location specified by 16-bit address in the operand are copied into accumulator. So the content of source is not altered. So the content of accumulator is altered. For example, LDA 2000H. So the 2000 is pointed by HL register pair, or the memory pointer is pointed the 2000 H memory location. The content of the memory location data, 8-bit data, is transferred into accumulator. So in this way, the memory location data is copied into the 8-bit register or accumulator A register. In this way we can transfer the data. So LDA is a this instruction copies the content of memory location whose the address is given within the instruction into the accumulator. So the content of memory location remains unchanged. Okay, the content of the memory location remains unchanged. So in this way we can copy the memory location data into accumulator. So this is example LDA 2000H. So the 2000H is a memory pointer, is a HL register, is pointed by the 2000H. In this location we can say 30 of the 8-bit data is stored in the 2000H memory location. So this data is copied into accumulator by using LDA, load accumulator, directly. So here the source, okay, the source operand is indicated that 16-bit address. So after the execution of LDA instruction, so the 2000H memory content data is copied or transferred into accumulator. After the execution, the accumulator content is altered, but the memory specified memory location is does not alter or unchange. Okay, in this way we can transfer the data from memory location into accumulator only. So another one, LDAX. So LDA is a 8-bit instruction, LDAX is a 16-bit. Okay, so operation. So load accumulator indirect. So it's a direct means LDA with the address, but LDA AX is a load accumulator indirect. So opcode is a LDA X. So the operand is a BD register pair, B register pair or D register pair. So B register pair is nothing but BC register pair, and D register pair is nothing but DE register pair. So LDAX B, or otherwise called LDAX BC, LDAX D, or LDAX DE register pair. So the content of the destination register pair pointed to memory location, the data is directly transferred into accumulator. So this instruction copy the content of the memory location into the accumulator. So previously we can stores the directly the address. Okay, the 2000 address is directly specified one of the operand in LDA instruction, load accumulator direct instruction. But here the 2000 memory address is loaded into a BC register or DE register, and the BD register and DE register stores the content, that is address of the content 2000 is copied, the content data is copied into the accumulator indirectly by LDAX instruction. So the content of either the contents of either register pair or memory locations are not altered. So the memory location and the contents of the register pair is not altered. So LDAX D. So this is a instruction. So in this instruction LDAX D, before execution, after execution. So the content of the before instruction, the accumulator stores any value. After the instruction, so the content of the 203H, we can say the memory location is a 2030H is addressed by the DE register pair. So this is a D register 20 and E register addressing 30. This is a 2030 is addressed by DE register pair. The content of the 2030 value is transferred into the accumulator by using LDAX instruction. So indirectly load the accumulator content with the address stored by DE register pair. So the after the execution, so the A register content, it may be override with a new value of 80. So the 80 is nothing but 2030H pointed by the DE register pair. So this D register is points the 2030 as a pointer. So HL register pointer is a memory pointer to points the memory content. But here we can using a D register as used as a memory pointer of 2030, and that location 2030 location is transferred or copied into the accumulator indirectly by the instruction LDAX D. So next instruction LXI, load register pair immediately. So load register pair immediately. Register pair means we can stores the address. Okay, LXI. So register pair means we cannot directly stores the value, but the register pair, that is a BC and DE and HL register. So these are the register pair only stores the address of 16-bit value. Okay, 16-bit value. So here we can stores the 16-bit value directly into the register. That register instruction is a LXI. So LXI is a load register pair immediately. So opcode is a LXI. So 16-bit value is stored into the register pair. So the operand or register pair. So the operand may be a register pair. So H register or B register or D register. So the operand LXI is a register pair with where source operand, it may be a 16-bit data. So 16-bit data is directly, okay, 16-bit data is directly load into the register pair. These instructions load the 16-bit data into the register pair. Example LXI H 2030H. So here the load, okay, load the register pair HL register pair 2030H data into directly the HL register pair. For before the execution or after the execution, before the execution, okay, before the execution, so the HL register pair points the 2030 and 2031H of 30 and 90. Okay, 30 and 90. After the execution of LXI H 2030H, we can transfers. Okay, we can transfers the H of 90 and L of 30. So 903H is a new address values loaded into the LXI H value. Okay, so this is immediately the value. Okay, the value is stored into the address pair of memory locations. So another one instruction LHLD, load H and L register direct. LHLD is opcode, operand is a 16-bit address. These instructions copy the content of memory location pointed by 16-bit address into the register L. It copies the content of the next memory location into the register H. So the next byte location instruction is directly copied into the H register. So HLD, for example 2030H. Okay. So before execution, the LHLD instructions, that is a 8500. Okay, 8500 any value. Okay, after the execution, the HL register is loaded into 8500 of a value 60. Okay, of the value 60 is loaded into the 8050H. Okay, load the immediate value into the HL register pair. So STA, it's also one of the data transfer instruction or copying instruction. STA is a stores the accumulator content into the memory. Okay, so all the 8085 instructions we can using the accumulator content into the memory for we can verifying the data. Okay, or evaluating the data by using accumulator content is stored into the memory. So this is one of the most important one of the instructions is STA. STA is a store accumulator direct value. So opcode is STA. The operand, it may be a 16-bit address. So the address, it may be a memory pointer addressing or HL register addressing the memory pointer addressing the location. Okay, so the content of the accumulator are copied into the memory location specified by the operand. So the address is pointed by HL register pair or memory pointer. Example STA 2000H. So 2000 is a your memory location. So this is a memory location, this is a destination. Source is a accumulator. So source value is accumulator. So accumulator value is a 8-bit data is stored into the directly stored into the 2000 H. So the H 2000 is pointed by HL register pair or memory pointer. So the memory content is directly loaded into the memory location of STA instruction. For example, before execution, the 2000 H of memory pointer addressed by the HL register pointed by the address 2000 H is any data. After the STA, so the accumulator content, okay. So the accumulator content we can say as a 50 as a accumulator content. So the 50 value is after the execution of STA, the 2000 H is loaded with a new value of 50. So before execution, so 2000 stores any value of the 8-bit data before execution of STA, but after the execution of STA 2000 H, so the 2000 H is nothing but it is a address, memory location address. So this address is pointed by HL register pair or memory pointer. So in this way we can directly load the accumulator content into the memory STA 8000 H or STA 4000 H. So different memory locations. So the memory location is addressed by the user in the program itself. So the address value is, we can store the address value we already know. So we can using the address value directly into the one of the operand of the microprocessor programming concept. So next one, STAX stores accumulator indirectly. So first one is directly, STA is directly stores the accumulator content into the memory location, but here the indirect method we can store the accumulator content into the memory. So STAX is a opcode and the operand is a register pair. So register pair. So here the memory address is pointed by a BC register or DE register pair. So the content of the accumulator are copied into the memory location specified by the content of the register pair. So STAX B. So B is nothing but BC register pair or DE register pair. So the content of accumulator, okay, the content of the accumulator is copied indirectly into the register pair of a memory location. So here we can say the accumulator content is 1AH. So before the BC register, so okay, STAX B register B, that means STAX B means STAX BC pair. So here the BC pair addressing the location, so anywhere in the location of memory. So for a say 8500, okay, so 8500, so in this address the BC register is pointed in the memory location. After the STX B instruction, so the 8500 pointed by the BC register, the content is override into a accumulator. So in this way, so we cannot directly load the value into memory location, but we can we can transfer the data into B register, but B register is pointed, BC register is a addressed pointing location, the data is used to store. In this way the accumulator content is indirectly stores into the memory location. So here in this instruction we cannot give the directly the memory location, but the memory location is pointed by one of the register pair, a 16-bit, that is a BC register pair. In this BC register pair addressing the memory location content, the accumulator data is stored in the location. SHLD instruction, store HL register directly, okay. So HL register is directly load the 16-bit address. So SHLD is a direct register address is stored in the instruction. SHLD is a opcode and the operand is a 16-bit address. For example, SHLD 2550, this is the address of 16-bit address of the HL register hold, okay, store. The content of the register L are stored in the memory location specified by 16-bit address. So the content of the HL registers are stored into the next memory location, okay. So the HL register next memory location, the content of the HL register pair is loaded into the memory. So this is a directly, okay, store the HL register directly into the memory location. For example, SHLD 8500, okay, SHLD 8500. Before the HL register that stores the address of 7080, okay, 70 80. After the SKHLD, so the value, okay, so the value of 8500, okay, the HL register pair addressing the location 8500 and 8501. So these values, okay, so the HL register pair values are stored into directly in the 8500 8501 memory location with 70. So these are 70 and 80 is a address of the HL register pair. So this is a address of the value, okay. This is a 16-bit address value directly loads into the memory location of 8500 and the next memory location of 8501. So this is a 16-bit address that holds the 8070, okay. So another one data transfer instruction is a exchange instruction. Exchange is nothing but it's a copy, okay. So this exchange instruction we can need two register pair, okay. Exchange HL register with DE register is also available. So exchange instruction we can only using the DE register pair content is loaded into the HL register pair. So H register stores the D register value and the L register value stores the E register value. So here the operand is none. There is not mentioned the operand, but it is optional. So opcode is a exchange XCHG. So XCHG is a exchange the data. So only we can changing the data XL with the DE register. So the content of the register H are exchanged with the content of the register D, okay, content of the register D. So this is a 8-bit, and the content of the register L are exchanged with the content of the register E. So HL register which is used to stores the address, and DE register is also address or data. So the HL register data is copied into the DL register with directly of exchange instruction. For example, before execution, DE register stores 2040 and HL register 7080. So this is a before your instruction. So these values are stored at D register stores 20, E register stores 40 and H register stores 70 and L register stores 80. After the exchange instruction, so the H register transfers into 20 and D register values transfer into H. So and L register content is transferred into E and E register content is transferred into L. So after the instruction of execution, D register stores 70 80 and HL register stores 20 40. Thus the D values directly exchange with are copied with the D register with the HL register. So the content of the HL register values copied into D register and the D register content of values copied directly into the HL register with the instruction of XCHG. So there is no operand involved in this instruction. So these two register pair content is exchanged, copied with one of the instruction is XCHG instruction. Next instruction SBHL, copy HL register to the stack pointer. So this operand is also none. The opcode is SBHL. These instructions load the content of HL pair into stack pointer. So stack pointer is also a one of the pointer 16-bit address. It stores the 16-bit address stack, okay. Stack pointer is also a 16-bit register and HL register is also a 16-bit register. It's a memory pointer. So the content of HL pair is copied into stack pointer. So 16-bit, another one 16-bit register, SP register. So before the execution, the stack pointer loads any address, okay, any address. So the HL register loads 2500, this is address, and after the execution SPHL, so the stack pointer loads the 2500 of the HL register address. So SP and HL register both of them stores the 2500 H of the memory content. So the memory content of 2500 is copied, the address is copied directly by SPHL register, okay. So another one XTHL exchange HL register with the top of the stack. So top of the stack. So this is a operand is none. Opcode is a XTHL. So the content of L registers are exchanged with the location pointed by the content of SP. So the content of HL registers are exchanged with the next location SP plus 1. Okay. So next location content is copied with the HL register pair. So example XTHL. So XTHL before the execution and after the execution. So before the execution, so L equal to SP and H equal to SP plus 1. Okay. Before the execution, the SP value is 2700. So HL is 3040. Example. So 2700 is 50, 2701 is 60 of the SP stack pointer loads the address of the value 5060. After the execution of HL, so after the execution, so the HL register value is altered with 60 and 50 of the memory location 2700, 2701 is a 40 and 60. So the stack pointer loads the HL register value and the HL register stores the stack pointer value. Okay, HL value is copied into stack pointer and stack pointer value is copied into HL register value. In this way we can exchanging the 16-bit address. Okay, 16-bit value in the SP value, SP register into HL register pair. So next instruction is PCHL. So this operand is done. The load the program counter value with the HL content. So this is a program counter. Previously we can discuss the stack pointer. So this program counter is also a memory pointer. Load the program counter value with the HL register pair content. So the content of the register HL are copied into program counter. Okay, HL register pair content is copied into the program counter. So the content of H are placed higher order byte and the content of LS lower order byte value. Example PCHL. Okay. So next instruction is a push register instruction. Push register pair into onto the stack. Okay. Push register onto the stack. Push instruction opcode push operand register pair. So the register pair is maybe P D H. Okay. So the content of the register pair are copied onto the stack. So SP is decremented and the content of the higher order register B, D, H, A are copied into the stack, and the SP again decremented and the content of the lower order register C, E, L flags are copied into the stack. So the higher order byte is copied into stack. The stack pointer is decremented by 1, and the CE register. Okay, the lower order register pair. So the lower order of the register C, E, L flags are copied into the stack. So again the decrement the stack pointer value by 1. So the stack pointer is decremented by 2 of the pair register value stored into the stack. So push B is the value. So the HL register value 42 and F2. This value is loaded into the stack of memory location 2097 and 2098. So this is in this way. So the memory location value is copied into the stack memory location. So pop instruction, pop stack to the register pair. So push and pop instructions are used only in the stack pointer. Okay, stack pointer using this push and pop instruction. Push instruction is nothing but it can store the data into the or value into the stack, and the read the data taken from the data from the stack by using pop instruction. To store, we can using push instruction. We retrieve the data from the stack by using pop instruction. So pop instruction, okay, the stack pointer value is incremented by 1. Okay, incremented by 1 for higher byte of data loaded retrieved from the stack pointer, and also higher order register and lower order register the retrieve the data from the stack, we can increment the stack pointer by 1, but decremented by the stack pointer by 2 by using push instruction. Pop instruction, we can use the data, we can retrieve the data from the stack pointer, the stack pointer is incremented by 2. Example, pop h. So the content of the top of the stacks are copied into the register pair. The content of the location pointed by the stack pointer are copied to the lower order register CEL flags, and SP is incremented and the content of the locations are copied to higher order register BDHA. Example, pop h. Okay, so the first one, push h, is a memory content where the data is copied into the stack memory location. So in this pop instruction, the stack memory location data is copied into the 8085 memory register or memory. Okay, so it's, most commonly we can using the register. Okay, so the 8085 register value is copied into the memory, stack memory, by using push instruction, and the stack pointer is decremented by 2, and the pop instruction, so the memory, stack pointer memory data is transferred into the mentioned register HL register pair. The stack pointer values incremented by 2. In this way, we can using the push and pop instruction, we can access the stack. So in instruction, copy the data to accumulator from a port with 8-bit address. So this is a port, IO port, copied into accumulator. So the content of the IO port value, so the port A, port B, port C is also ports are available. So the ports, the transfer the data from memory to peripheral devices and peripheral devices memory by using a port. So this is a 8-bit data, the port address. So each port having a different port address. So we can mention the port address, and the data is copied into the accumulator. So this is external peripheral device send the data into the memory location. In this way, the accumulator copied the data from the port and transfer into the memory. So in 8-bit port address, so the content of the IO port are copied into the accumulator. So in 8CH means, so 8C is a port address is copied into the accumulator. So this is a port address. Before the execution, the port address 10 is loaded, but the accumulator content is anyway, any data is stored in the before the instruction of in 80H, but after the in 80H. So 80 is not a data, 80 is a address of port address. So the port address 80 value is transferred into or copied into the accumulator. In this way, we can accessing data from the port into the memory. So only the accumulator we can using send the data into the port and receive data from the port. So send and receive the data from the ports, we can using only a register is a register, only using the port is possible. Other than A, we cannot using the register for accessing the port value, port address. So out instruction, so in instruction, receive the data from port into from the port to accumulator. Out instruction, so accumulator content is transferred into the port. Okay, copy the data from the accumulator to a port with the 8-bit address. So output is a opcode is a out, operand is a 8-bit port address. So the content of the accumulator are copied into the IO port. So out 70H. So the accumulator content value is transferred the port address of 78. So port A, port B, port C. So the 78 is a port address. So the accumulator data is transferred to the port address of 70H. So before the execution, the port address stores any value of 10, and we can say accumulator value is 440. After the execution, out 50H. So 50H is a port address. So the port address is loaded with your accumulator value of 40. So after the execution, out 50H. So the accumulator content and the port 50 address is also same. In this way, we can send the data to the port. Okay, we can receive the data from the port by using in instruction. We can send the data to port by using a out instruction. So in and out instructions are most commonly used to accessing the port of 8085 microprocessor. So second instruction set. So so the first category of the instruction set, we can studied the move instruction. Okay, move immediate, store, and store 16-bit directly value directly, indirectly, push, pop instructions are studied in the first category of data transfer instructions. So second category, we can study the arithmetic instructions. So these instructions perform the operations like arithmetic, addition, subtraction, increment, and decrement operations. So the arithmetic instructions are addition. Okay, arithmetic instructions are addition, subtraction, uh, increment, and decrement operation. So 8085 microprocessor is not directly multiplication instruction and division instruction, but 8051 microcontroller is having a multiplication instruction and division instructions. But the multiplication instruction and division instructions are performed by 8085 microprocessor by repeated addition by means of multiplication, and repeated subtraction by means of uh, division operations are performed by the microprocessor. So addition. So 8085 addition instruction, any 8-bit number or content of the register or content of the memory location can be added to the content of the accumulator. So in the arithmetic instruction and logical instruction, one of the operand we can using as a accumulator. So accumulator stores the results of the arithmetic and logical instructions. Okay, one of the operand, it must be a accumulator. So any 8-bit number or content of the register or content of the memory location can be added only to the content of accumulator only. Other than accumulator, we cannot possible for addition. The result, the sum, is always stored in the accumulator. So accumulator is a 8-bit register or a register. So only stores the result of the arithmetic and logical instructions. So no two other 8-bit registers can be added directly. So for example, add B, C is not possible. Add D, E is also not possible. So no other two 8-bit registers not directly added. So only a accumulator is added with another register memory location is possible. So example, the content of the register B cannot be added directly to the content of the register C. Okay, so first instruction is add instruction. So this add instruction, the operand may be a register or memory content. The register, or it may be a B register, C register, D register, and E register. The memory content, memory location is also added with your accumulator. So the opcode is a ADD, operand is a operand is a R or M. So ADD R comma A. So this is a accumulator. Accumulator is a source operand. R is maybe a B register, C register, D register. So in this way, the operand A register is optional for add or instruction or add memory location. So the description, add a register or memory location to only to the accumulator. So the content of the register, any register B, C, D, E register or memory location is added, or the content value is added to the memory accumulator content value, and the result is stored in the accumulator only. Okay, if the operand is memory location, it is address is specified by HL register pair. So the operand may be a memory location, means the address is specified by the HL register pair. The HL register pair point out to the memory location data is added with your accumulator, and the result is stored in the accumulator only. Example, add B and add M. So before the execution, A register contains 4 and BC register. Okay, so BC register, DE register pair, HL register pair. So we can using add C. So before the execution, we can say assume A register is a 4 and C register is 5. After the execution, so the A register content is override with your sum value. Result value is stored in the accumulator. For example, A equal to A plus C. So A value is a 4 and C value is a 5. 4 plus 5 is a 9. So the 9 result value is stored in the accumulator A. And the C register content is not altered. So 5. So in this way, we can adding the data. Okay, in this way we can adding the data with register to register. So add C is the C register content value is added with your A register content value, and the result is stored in the A register content value. So the previous A register value content 4 data is override with answer, the sum value stored. So only after the execution of the arithmetic and logical instruction, the result is stored in the accumulator. Okay. So add m for next instruction, add m. The memory content value is added with your accumulator content value. So for example, we can say the value of A is stored at 4 and the HL register pair pointed at by the HL register pair pointing 2050H value is 10. So the 10 value is added with your A. So A equal to A plus 10. A equal to A plus M. So M value is 10 and A value is 4. So 10 plus 4, 14. So the 14 value is stored in the accumulator. Before the execution, the memory pointer 2050 loads 10 and A value 4. After the execution, so A equal to A plus M, A value is 4, M value is 10, 10 plus 4, 14. The 14 result value is stored in the accumulator. But 2050, the HL register pair point out the memory location content, does not change. 2050 is value stored in the 10. But the accumulator content value, the value of the operand value, 4 is overridden with your sum value of 14. So next addition with carry, ADC execution. Okay. So the carry is 1, add A carry register content is 50 and ADC register content is 5. It may be ADC. So A equal to A plus C plus CY. So A is a accumulator, carry. So the content of the register or memory. CY is a carry flag of added to the content of the accumulator. Carry flag is also 1. Without carry, so we can add ADD. So A equal to 50 with plus carry plus we can 1 using ADC. Okay. Instruction. The result is stored in accumulator only. The carry flag. If the operand is memory location, it is address specified by the HL register pair. So all the flags are modified to reflect the result of the addition. Only. So previously we can the flag register values are unchanged, but in this way ADC, so the flag values are modified. For example, if it is the result is negative or positive or parity value of the accumulator, so that depends upon the parity flag, 0 flag, carry flag, or altered with the instruction of ADC. For example, ADC carry or ADC. So the 56 is stored. So ADC M. So the carry flag is 1 and the accumulator content is 06. Memory content value is 30. So A equal to A plus M plus carry flag, carry value. A equal to 6 plus 30 plus 1. So 37. So 37 value stored in the accumulator and the memory content value 30 is not altered and it's also a carry flag value is also not altered. So only content of the accumulator values are altered with the ADC instruction. Next one, ADI. Add immediate value to the accumulator. ADI is add the immediate value. So the operand values, one of the 8-bit data is directly added to the accumulator content. ADI is add the accumulator content with the immediate value of 8-bit data. So add immediate value to the accumulator. The 8-bit data is added to the content of the accumulator. The result is stored in the accumulator only. So all the flags are modified to reflect the result of the addition. So for example, ADI 45. So 45 is a data. This 45 data is added with your accumulator content and the result is stored in the accumulator only. So before the execution, A value is 3, any value, ADI 5. So the data 3, okay, 3 plus your 5. 5 is the immediate value. So 3 plus 5 immediate data, the value stored 3 plus 5, 8. So after the execution, the accumulator content is loaded with 8. The result is stored in the only stored in the 8. So here ADI instruction, so immediate data is also one of the operand of the ADI instruction. The result is stored only in the accumulator content only. Subtraction instruction, any 8-bit number or content of the register or the content of the memory location can be subtracted from the content of the accumulator by using subtraction instruction. The result is also stored in the accumulator only. So the subtraction is performed by 2's complement form. Okay, subtraction is performed in the 2's complement form. The result is also result is negative. It is stored in the 2's complement form. So the result it may be positive or negative. If the result is negative, the 2's complement form of the result is stored in the accumulator. No two other 8-bit registers can be subtracted directly. SUB instruction. So subtraction instruction, it may be operand, register or memory. So subtract the register or memory from the accumulator. The content of the register or memory locations are subtracted from the content of the accumulator. The result is stored in the accumulator only. If the operand is a memory location, it is addressed specified by the HL register pair. All the flags are modified to reflect the result of the subtraction. So example, sub B and sub M subtraction. So before the execution, A is stored 9. If I assume that A equal to 9, C equal to 4, and subtract A is equal to A minus C. So A equal to 9 minus 4, that is a 5. The 5 value stored after the execution of the subtraction instruction. We can using memory. So memory stores the value of 10 and A equal to 14. So 14 minus 10, 4. The 4 value stored in the after the execution of accumulator. So in this way, the C register content and the memory content is does not affect. So SBB. So this is a subtraction with borrow. So the operand may be a register or memory location. Subtract the register or memory from the accumulator with the borrow. The content of the register or memory location borrow flags, that is a carry, are subtracted from the content of the accumulator. The result is stored in the accumulator. If the operand is a memory location, it is address specified by HL register pair. All the flags are modified to reflect the result of the subtraction. Example, SBB or SBB M. So this is a SBB C. So A equal to A minus C minus carry. SBBM means A equal to A minus M minus carry, with subtraction with carry flag, and subtraction with carry flag of memory content or register. In the before execution, the carry equal to 1, A equal to 8 and C equal to 5. So A equal to A minus C minus Cy. So A equal to 8 minus C, 1 minus 5. So the result is 2. The result is stored in the 2 after the execution of the SBBC. If we can using memory content value to the subtraction, so the memory content value is 2, carry value is 1, and accumulator content value is 6 assume. After the execution, so A minus M minus Cy, A equal to 6 minus 2 minus 1, so the value is 3 is stored in the accumulator. So the content of the memory location values does not affected, and also and we can using the register C, so the register content value is not altered, but the result is stored only in the accumulator. So content of the accumulator is modified with your sum value, result value stored in the accumulator. So next one, subtraction with immediate from the accumulator, SUI. Subtract immediate from the accumulator. SUI, operand is 8-bit data. So the 8-bit data is subtracted from the content of the accumulator. The result is stored in the accumulator only. All the flags are modified to reflect the result of the subtraction. SUI 0. So the 0.5 is a direct value. The direct operand value is subtracted from the A content. If I assume that A is equal to 8, so subtract the A value 8 minus 5. So the 3 is stored in the after the execution of the your accumulator. So here the 5 is a operand. One of the operand is subtracted directly from the content of the accumulator, and the result is stored in the accumulator only. So the expression equal to A equal to A minus D data. So the data is 8-bit data. The data it may be a 5 or 3 or 4. So the A equal to A minus D. So the result is positive or negative. If it is a positive, there is no 2's complement form stored in the accumulator. But if the result is negative, the 2's complement form of the result is stored in the accumulator only. So increment and decrement instruction is also a arithmetic instruction. So the 8-bit content of the register or memory location can be incremented by 1 or decremented by 1. So the 16-bit content of the register pair can be incremented and decremented by 1 is also possible. So the 16-bit register pair is also decremented and incremented by 1 by using increment decrement operation, or 8-bit content of the register is also incremented and decremented by 1 is also possible. So the increment decrement performed by any register or memory location is also possible. So INR, so increment the register value by 1. So register or memory content. So the content of the register or memory location are incremented by 1. The result is stored in the same place only. If the operand is memory location, it address specified by the content of HL register pair. Increment B or increment M. So the increment B register means the B register value assume that be 10. So after the execution of increment B, so the value 1 is incremented, R equal to R plus 1. So 10 plus 1, 11. So 11 is stored in the after the execution of the instruction. And the memory content increment M, so M equal to M plus 1. The memory content is pointed out by the HL register pair of 10. So the 10 plus 1, 11. 11 is stored in the HL register pair of 2050 of the same memory location. So INX sketch is incremented by HL register pair by 1. Previously we can increment it by the 8-bit register, but we can using the pair of the register BCDE HL register pair, the increment the HL register pair by 1 by using INX or the content of the register pair is incremented by 1. The result is stored in the same place, INXH or INXB or INXD. So before the execution, the HL register pair, okay, HL register pair loads the value to 10 to 0. So RP equal to RP plus 1. So this is a value 10 plus 10 20 10 0 20 is incremented by 1. 10 0 21 is loaded after the execution of the INH. So decrement operation, decrement register or memory, decrement register memory by 1. The content of the register memory locations are decremented by 1. The result is stored in the same place. If the operand is memory location, its address is specified by the content of HL register pair. Decrement B, decrement C, DCRB, DCRM. So the value, okay, before the execution, the value of E, assume that 20. So in decrement by 1, R equal to R minus 1. So 20 means we can store the after the execution 19. So with the memory content DCRM, so M equal to M minus 1. So memory content value is stored at 2050 is pointed by HL register pair. 21 means 21 minus 1, that is a 20. So in this way, the increment and decrement the register content by 1. So if it is a 16-bit register pair is decremented by 1, DCX R. So decrement register pair by 1. The content of the register pair decremented by 1. The result is stored in the same place. Decrement DCXH, DCXB, DCXD. So this way, before the execution, DCXH HL register pair is loads 10 to 1. So RP equal to RP minus 1. So 10 minus 1, 10 to 1 minus 1, 10, 20. HL register pair, the whole loads new value of 10, 20 after the execution of TCXH.